All right, so video 3 for objective or for lesson 2.5. This is objective 5, the last one. Use Descartes' rule of signs. Okay, so Descartes is the name of a French mathematician. His name was René Descartes. And anyway, this was his rule of signs. He, like you, may have been a little frustrated with the rational zero theorem, or may have been developing an alternative to that, knowing about it or not knowing about it. I'm not sure when each of these came into existence as far as being written down as mathematical laws. But we are going to use Descartes' rule of signs to determine the possible number of positive and negative real zeros of a function. And I have written down here checkpoint 7. I'm kind of confusing myself. I'm not sure if it's checkpoint 7 or example 7. I'm going to trust you to go to your book and look that up yourself. Okay, so again, we have this word possible like we had with the rational zero theorem. This is the possible number of positive and negative real zeros, meaning the maximum number of x-intercepts on the positive side and the maximum number of x-intercepts on the negative side. Okay? And this is how we tell. Okay? It helps us narrow the list from the rational root or the rational zero theorem. So that's helpful. Before I go testing, I always consult my Descartes' rule of signs to help me narrow that list before I run off and test something that I didn't need to test. I'll show you what I mean. So what we do for the positive, okay, is we look at the f of x that was given, and we look for the number of sign changes. Okay, so this is what it looks like. F of x, it starts positive. X cubed is positive x cubed. There is no negative in front of it. We don't count that as 1. It's just where we start. And then we look to see if it ever changes sign. So stays positive, stays positive, stays positive. So how many sign changes are there? There are 0 sign changes. And if there are 0 sign changes in f of x, then there are 0 possible positive roots. F of x goes with the positive. Okay? So the implications for rational zero theorem is that I wouldn't even test any positive values in that plus minus p over q. Don't even test them because there's no way they're going to work. Descartes' rule of signs says so. Let's go on and look at the negatives, okay? So same function, but now we're going to look to see how do we find the possible negative rational or negative roots. This would be rational or irrational. That's another difference from the rational zero theorem. We actually check f of negative x, okay? So this is the same test that we do for symmetry, either y-axis symmetry if it's an even function or origin symmetry if it's an odd function. You don't have to do another test. You do the f of negative x, and this test will give you, depending on how you look at it, it can tell you symmetry. It can tell you if the function is even or odd. It can tell you how many possible negative real zeros we have. Okay? You just have to know how to read the test. So here's what I mean by f of negative x. In f of x, we're going to substitute a negative x for every x, and then we're going to simplify that. So looking back here, 5 times negative x will be negative 5x, plus 4 still back here. This and negative x squared, the squared will get rid of the negative, so this one's still going to be positive 2x squared. And if you take a negative x and you cube it, that value is negative, okay? Because you have like a leftover negative. So when you look at this one, and I see a mistake I've made, negative x cubed, this should be a positive 2x squared minus 5x plus 4. Okay, so when we look at that, we need to check and see how many sign changes do we have in f of negative x. Okay, so it starts negative. That doesn't count. It changes to positive. There's 1. It changes back to negative. There's 2. And then it goes positive. There's 3. So the number of sign changes we have in f of negative x is 3. What that means is that we have 3. I'm going to have to change what I have written here. We had 3 sign changes. So that means there are 3 possible negative roots. On the other page, remember that we didn't have any sign changes, so that means 0 possible positive. But there are 3 possible negative. And we actually, if there aren't all 3 being negative, remember this is a cubic, so we're going to have 3 roots. If all 3 aren't negative, then there may be a pair of them that are complex. Complex roots always come in pairs. I talked about that in the very first video. I think it was for this 2.5, the complex conjugates. So if all 3 of these roots for this cubic are negative, then that's satisfied. But if 2 of them are complex, then we may only have 1 possible negative root. And if it's 1 negative, then that would mean 2 of these would be complex. Okay? You will always start with your sign changes and then you say or by stepping down by 2's. Okay, so 3 and then 1. Okay, so implications for the rational zero theorem. Like I said before, when testing that, I would only do the negative values. Remember, you just go and you find one that works, and then you use the depressed polynomial and try to factor from there. All right, let's do one more example, okay? Hopefully I've done this one all correct this time. Find the possible number of positive and negative zeros of f of x equals x to the 5th minus x to the 4th minus 7x cubed plus 7x squared minus 12x minus 12. The first thing we're going to do is check the positives, okay? And we just keep our f of x and we count our sign changes, all right? So I want you to count your sign changes. I'm going to count my sign changes. I'm seeing 3 sign changes. I'm seeing that it starts positive. That doesn't count, but it changes to negative. Now it counts. Changes to positive, changes back to negative. That's 3 sign changes, okay? So starts positive, and then we can see the change there. 3 sign changes, so there are 3 possible positive real roots or 1 positive real root, either with a couple negative or with a couple complex. 3 or 1. Okay, let's go to the negative and count that. All right, so if we look at f of negative x, starts negative. Here. Okay, so I couldn't really say it starts negative till I got down to this step, so sorry, that's kind of misplaced. But it starts negative, and then it changes to positive, and then back to negative. So this is also 2 sign changes. Started negative, changed to positive, and then back to negative. 2 sign changes. So that means there are either going to be 2 negative real roots or there are going to be 0 negative real roots. Okay? So the way these fit together up here, this is a quintic function, so you have to have 5 roots. You're either going to get 3 positive with 2 negative, or 3 positive with 2 complex. Or you could have 1 positive with 2 negative, and then that would leave 2 more for complex. Okay? All right. So Descartes doesn't find the zeros for us. It just helps us narrow that rational zero theorem to tell us what our possibilities are. All right, so I want to give you a couple of remembers. Make sure that you are thinking about when you're going to take all 5 quizzes. You have to take those within 2 days, or at least 2 days before your chapter test, which is planned for the end of next week, like the 31st, I believe is what I have planned. Any retakes have to be done within this time frame as well. I would like to give you 1 day before, but I'm not going to be here next Thursday. So for this chapter, you're going to have to do any retake quizzes 2 days before the chapter test. If you do not take a quiz, it will be a 0. If you want to take it after the 2 days, which isn't even an option, it will normally be half credit. This time it's a 0 because I won't be here. Make sure you go back to the video tutorials to help you when you get stuck. And please, please, please be making a list, note cards, whatever, of all of these theorems in this chapter. This is huge for you. You have to know one theorem from the other. Rational root theorem from remainder theorem, from factor theorem, from complex conjugates. You've got to know all of those. Okay, so start quizzing yourself, and please, please let me know what things you're getting stuck on.